Very good morning, students. Myself J. Vishakan. I handle the subject engineering mechanics for second semester. The subject code of engineering mechanics is GE8292. See, engineering mechanics is a core subject for mechanical and civil engineers, right? So, what do you mean by engineering mechanics? Engineering mechanics is a branch of science which deals with the behavior of the body with a state of rest or motion subjected with the action of forces, right? Why engineering mechanics is required or necessary? See, in the today's world, the planning, designing and the construction of different or the various types of structures and machines like bridges, multi-story buildings, aircrafts, robots, etc. are done by engineers by applying the principle of engineering mechanics. One who knows or one who understands the engineering mechanics can become a successful practicing mechanical engineer or structure engineers or the process engineers or even a software engineer or a successful software engineer who would need the mathematical logic to comprehend the problems. So for this session, I am going to just give a brief introduction about the syllabus of engineering mechanics. So the first unit, which talks about the statics of particles. So, by the way, what do you mean by particle? A body is idealized. A body is idealized of a particle in statics when the shape and size doesn't affect the solution to the given problems, and the mass is assumed to be concentrated on a specific point. That means mass is concentrated on a point or a specific point. When the system of concurrent forces applied on the body can be idealized as particle, right? So let me just give some lights on each chapters of the statics. What do you mean by statics, by the way? The study of a body which is at rest, that is statics, right? So the introduction of the statics in detail, then units and dimensions of the variables, then laws of mechanics. So there are even 9 laws as far as engineering mechanics is concerned. Then system of forces, right? Then equilibrium condition, vectorial representation of forces, then forces in space. Forces in space in the sense, I mean, in the 3 axes, that forces are acting in the 3 directions, that is the 3 planes, right? So let's move to the next unit, which is equilibrium of rigid body. What do you mean by rigid body? A rigid body is a body having space or the mass and the dimensions. See, the body which doesn't deform under the action of force is rigid body. So we will see in detail about each chapters in the upcoming videos. So for this session, I am going to give a brief introduction. What are the chapters which is covered in each unit? So as far as second unit is concerned, free body diagram, that is FBD. When the body is in equilibrium condition, going to find the unknown forces, and action and reactions, which talks about the Newton's third law. Then moment and couple, there's moment. Then by using the Varginan's theorem, going to find the moment. Then equilibrium of rigid bodies in 2D and 3D. So this 3D is nothing but the vectorial representation, the forces acting in the 3 different planes. When you talk about properties of surfaces and solids, the centroid, center of gravity, center of mass and moment of inertia, parallel axis theorem, perpendicular axis theorem, product moment of inertia, polar moment of inertia, then principal moment of inertia and mass moment of inertia. So this is used to design the support of structures and beams on the support reaction due to the own weight acting through it. So that covers in the chapter 3, that is your unit number 3. When you talk about unit number 4, which is dynamics of particles, What do you mean by dynamics? It's a branch of mechanics of rigid body, right? Dynamics means a body which is in the study of the body which is in motion, right? So displacement, velocity. So velocity again it talks about the magnitude and direction, right? So which covers in the dynamics, right? So acceleration, rectilinear motion, then curvilinear motion, Newton's law of motion, which is nothing but the D'Alembert's principle. By using D'Alembert's principle, we find the variables like velocity, acceleration, then the force which is acting upon the body. Then by using the work energy equation or work energy principle, we used to solve the different problems, right? Then impulse and momentum. That is, then next the impact of elastic bodies, which covers the fourth unit, which is dynamics of particles. Let's move to unit number 5, which is friction and rigid bodies. What do you mean by friction? When the two bodies are in contact, when the body slides over another body, when a body which slides over another body, a force is extracted, right? Extracted on the surface, on the contact by the stationary body on the moving body. So that we are going to cover in the unit number 5, right? Frictional force, loss sliding friction. So sliding friction, which covers the ladder friction, then belt friction, then screw jack, which covers under the loss of sliding friction. Next, wedge friction, the friction between the wedge and the body. Then rolling resistance, general plane motions of the rigid bodies under the cylinder, sphere, disc, wheel. So in broadly, if you look at it, the first 3 units, that is unit 1, unit 2 and unit 3, and the friction, that is the first of the 5th unit. So totally 3 of units, this is of statics. So that is a static object. So when you talk about the unit number 4 and the another half of 5th unit, that comes under the dynamics. So in totality, 3.5 units covered under the chapter statics, that is static particles, and the 1.5 unit, the 4th unit and the second half of the 5th unit comes under the dynamics of particle. So in the upcoming videos, I will explain in detail about each and every chapters of this unit, and would solve the problems in the different categories. Okay, till then, thank you.